as of April 24th, in our checking account, we have, you just bought one.
Yes.
So, Jerry, it's all yours.
Thank you.
Thank you very much. We'll be two-fisting it here. You're doing
The screen went black.
just because I got it here in black. Wait a minute. Check this out.
There we go. If I hit 4, it goes black.
Okay.
If I hit 4, it goes black.
Oh, hold on a second. Hold on. Hold on. Hit 4. Here, hold this.
Okay.
And does it all. Presentation, set up the computer.
Did I ever tell you the joke about when I was younger and I used to drink? No, I didn't say that. When I was younger, I used to drink, okay? And I got so drunk one night, I fell out of a 2-story window, landed down on the sidewalk below. And a bystander comes over, a good Samaritan bystander comes over and he says to me, he said, "My God, what happened?" And I said, "I don't know, I just got here."
Oh, yeah. I gotta follow that.
Any worse?
Thank you. Do we have a record going?
Yeah.
All right, very good.
Told me not to forget.
All right, that's very good. He didn't forget. Well, good evening, gentlemen. Everybody here and everybody at home. We got a good crowd. We got about 18 here.
Do you want to do the inset window? Like you did for the Turners?
You can. Show how to do it.
I don't know how.
1 second. Something else.
Okay, no jokes. It's a tough crowd.
You're not gonna work the Christmas party this year, are you?
Hey, it was clean, okay? You can actually tell that one. I could tell you the dirty one about my tattoo, but no. No.
We're
Well,
trying to get an inset window so that we can see Jerry in the corner as well as his PowerPoint presentation. That way, because quite often Jerry will point on the screen so we can watch him do that as well. Anyway, I'm just telling Ron so the guests out there understand what we're doing. There we are. There we got it. Oh, God.
okay,
Jerry up there.
yeah, hurry.
Murphy's Law.
I'm back. I was trying to read upside down with my glasses on. I can't do that. All right. So as I was saying, thank you. Welcome for being here tonight. There's about 18 of us here tonight, and I don't know how many, about 20 plus online, 11 online. See, I'm looking at the wrong number. I had my glasses on again. All righty. That's pretty good. All right. Go through how I made this Beads of Courage box. So right here. This was made with traditional tools, and then after that, I'll show you what was the process I'm going through to do a second one using my CNC machine. Right. This was the inspiration of right here, this magazine I picked up, a book rather upstairs, probably about a year and a half ago. So I think those would make nice Beads of Courage boxes. And I was trying to decide which one I might want to do first. So I thought, well, this would be a nice one. It's sort of rectangular, octangular. Excuse me. Not too difficult to do. And it's sort of round, like most of them that they get. All right. So that was my first choice. And you can see it's got there's a bottom ring and a top ring. All right. You cut them out on a square saw. And there's the second ring that you stack them up on top, alternate stacking them up. That's what gives you this weave type pattern in here. Oh, when I saw that, that's the top with all these cutouts. And at my age, I didn't think I had the patience to do all of that like I used to as a kid. Yeah. Or type, true, yeah, too, yeah. First you gotta drill all those holes, and then you gotta come back and one at a time put that scroll saw through each hole and cut them out. So our second choice was this one here, which you see right there. Fewer cutouts, none. And it's made out of sticks. Okay, so I just got to rip sticks and cut the sides on them and stack them up. So that's pretty easy to do. And there's what the bottom and top looks like. No cutouts again. So now I just try to say, what am I going to make it out of? Well, I thought, well,
Dave McBride is saying that the sound is horrible.
try
But
on the little box here, try putting a down arrow for volume on the left, under the mic, where it says mic 1.
on this box.
Yes, mic 1, the red button there on the left. Or should we say a down arrow?
Okay.
How about that, David? Is that better? You can talk, David. He can unmute himself. Hit your space bar and talk, David.
David, go ahead and hit your space bar, unmute yourself.
The sound is a little better. Keep talking. I'll let you know.
All right, well, hit it down one more. Better? How about that? I've got the microphone down a little far too. I could have been too high on me. Okay? Okay.
Yeah, let's keep going.
All right, we'll try this. All right. I think on this whole setup that we've got going here for the past year I've been working on, we've got everything down really good except for the audio. And I just can't get audio to come through clear. See, we have to get audio for the people coming in with questions from the Zoom. We have to get audio for the people in the audience here. We have to get audio to be recorded on the tape. Okay? And they're all mixed up on all different things that we have to try to get married together. So, and we have to get audio for the guys at home to hear it. So that's one thing I'm still working on. And we'll try to get it straightened out as soon as possible. So I was looking at what kind of wood I thought I might want to use. I like using maple. It's a nice, solid, hard wood, easy to work with, or poplar. So some time passes, and at Menards, and they've got the 11% sale almost every week now. Right? So I'm looking to see what kind of wood do I need. Right? So I see this pieces of 1/4 inch by 5.5 inches wide by 5 foot long. I said, well, this would be perfect. Right? So I buy 2 pieces. They didn't have any maple that size, so I had to buy the poplar. Right? And then some time goes by and I had a memory lapse. Okay? I was thinking about building those octagonal box, not this one, when I bought the wood. Right? So there's the wood I bought. It's still sitting there, still in the cellophane. Right? What happened was, if I went into another room, right, there's a whole stack full of 1/4 inch maple, 5.5 inches wide. Okay. So I had what I needed, and I didn't know it. Okay. And I've actually bought that wood a couple of years ago from Oshkosh Design in Winneconne when we had a tour up there with the Turner, and it was a very nice tour. And she invited us up for a garage sale that they had, and I spent well over $100 in wood, that scraps that they had. Right? And this is the first project I'm using it on. So the box size is, according to the Beads of Courage people, which is listed on the American Association for Wood Turners website here, a turn box is 5 by 6 inches in diameter, 4 to 5 inches high. Gives you that particular inside volume. A rectangular square box is 4 inches wide by 6 inches long, 4 inches high, with a 93 cubic inch volume. this particular box, and I didn't use the plans out of the book exactly as they were, or even some of the shape is not exactly the same. I made mine 3.5 by 7.5 by a little over 3 inches high. So I'm pretty close to what they're looking for. First thing I did, I started making CAD drawings of what I wanted to do. There you can see the top and one of the sides there and the different pieces on how they're drawn. I usually use SketchUp or Libra or ViaCAD. Just depends on which one I feel like doing that particular day. So I started cutting, taking the wood that I had, those maple pieces, and I cut them into 3 8-inch wide strips, like these guys here. Okay, and then made full-size templates. But then I got a different idea. On the jigsaw, this is how they are in the book. Right? To show the what's the bump with the dowel rod there going through, you actually have to cut those out, right? And then cut out the other curved part there. I wanted to use dowel rods in there instead to make it look more even, more round, instead of trying to cut those out and trying to get them all lined up. So that's what I decided to try to do. So trying to drill those holes down through there, you got to get them through every piece the same way for every piece. You have to have matching parts for the 2 different sticks that you're working with, right? And then you have to stack those up and try to get those dowel rods in there, right? So I set up a jig, which is just a corner jig here that I clamp to my drill press. These are spacer blocks that I made for the holes. What you do is I put the first piece in, drill the first hole, put a spacer block in, drill the second hole, put another spacer block in, drill the third hole. And I did that for all the pieces, different spacer blocks for the long ones and for the short ones. Right? And I thought that should be pretty good, right? And I used a nice brad point drill bit, or Forstner, can't tell from here. And then I made a full-size template to put the curves in. Okay. You see it like that. Now I go over to the bandsaw. I cut it out on the bandsaw. And I go to the drum sander to sand it down to get the ripples out from the bandsaw. Okay. And the other parts here where we got these 2 dowel rods in the corner, I couldn't get down in there with that drum sander. So I had to use a half-round file and file it a little bit inside there. Okay. And then I cut my dowel rods off. And that little red thing, that's a welding corner magnet there. Works great on the bandsaw for doing same part lengths like that. And then, wouldn't you know, and I knew this, and then everybody knows this, I drilled the holes to 3/16, about 3/16 dowel rods, right? Have you ever seen a dowel rod that was 3/16? No, they're always bigger, right? And if you're lucky, you'll find one a couple, sometimes smaller. Well, mine were all too big. So I took a piece of metal, drilled successively larger holes in the piece of metal, and then I took my dowel rods and hammered them through the next hole, then the next hole, taking shavings off to get those suckers down to 3/16. I didn't want to try drilling them all again to those pieces because it was going to be a mess, I know. Okay. So then I dyed them red. Okay.
Is that a trans tin dye?
Yes. Right. Come on. Come on. Come on. Don't do that to me. Here we go. Come on. This is an animation that's supposed to be working better than this in SketchUp of how I assembled, how the pieces are assembled. It took me over 2 weeks to do this little thing that runs about 20 seconds or less. Now, this is how you have to add a plane stick top and bottom. And I use my same pointer jig to do that, to get everything all lined up and pushed together. And this is what the side's supposed to look like, right? And I used a full side template to do the top and bottom, cut them on the jigsaw. And this is what the assembly looks like, right? Just like you see here. Right? Now, instead of putting the fancy holes in these rings here, I just put the one drilled hole in there. Right? Put a square board on the bottom of the lid to retain it into the box. Right? This is a rough sketch of the pull. There's my pull. When I was doing the bead, I got a catch and tore it off. So I just cut it all the way off and went that way with it. Then I painted the pull and a big black circle on the top. Right? You know, so why is he putting a circle like that up there? Well, I wanted to make a design on the top. So I decided to try doing what's called a mandala design. And it's made with dots. Right? And these are the dotting tools. And these are homemade tools for this particular job. On the far left, that blue thing in the end there, that's a map tack, right? Stuck on the end of a dowel rod. The next one is a glue stick. The next one is a ball bearing glued to a popsicle stick. Next one is an eraser, right? The next one is the Q-tip rod without the tip on it, right? The wax, I mean the cotton, thank you. Next one is a dowel rod with two different size pin heads on it. Straight pins, got two different diameter heads on it. The next one's a toothpick. Okay. And then over here, these are, just went right out of my mind. Embossing tools. Okay. And there are different diameter balls on the end of those embossing tools. I bought those many years ago, thinking I would do something with them, not thinking about this at the time. Okay. You know, when you go to the trade shows and stuff, they've got those booths with those little scissors and tweezers and stuff like that. Yeah, that's where I got them. All right, the board at the top is my practice board. All right, so I try it there before I went to here. All right. So there was the top with the beads of courage, a ceramic disc in it, and that was my first dots I did. All right. I'll explain to you how I did that in a second here. Here's the top with a black dot, the first set of rings there, red dots. And I just use normal acrylic paints that you buy at Hobby Lobby or Michael's. Okay. You have to get the right consistency in order for the paint to flow correctly and to form correctly. Because if it's too thick, you'll leave glops on it, or you'll pull some of it off and you'll get a rough bump. If you get just the right consistency, it either makes a perfect circle or a little domed circle on there. Right? That's what you're looking for. And to thin it, you can use water, or you can use alcohol, or you can use a flow extender, which is what I use. And it takes 1 drop of flow extender to 20 drops of water. And what I do is I just squirt a little bit of paint. This is a ceramic tile. I just squirt a little bit of paint on the tile and 1 drop from a Q-tip of this diluted extender, and that makes like a perfect consistency. And there's some more dots. And what you do is you got the paint sitting on the ceramic tile, and you take the tool like this, and you dip it in the paint, and you come over and you just touch the wood with it and lift it up. Go back, get the paint, come back over, do another dot. Get some paint, come over, do another dot. Get some paint, come over, do another dot. All right, and you just keep going around like that. And you can put these, that's like a white pencil to lay out your grid, so you can hope to stay within the grid so you get the dots even around. All right. Being my first one, I missed the grid that I put on there in places. So, and then you use different diameter tools to get different size dots. All right. And what's really cool is, now this is the finished one here. That's what you see on the top of the top here. is see these arcs in here, like that, all those different size dots. Well, if you take one tool, dip it in the paint, make your dot, make another dot, make another dot, make another dot. As you keep making successive dots with that one dip of paint, it keeps getting smaller and smaller and smaller because you got less paint on the dot on the tool. So it just automatically happens. Okay. But you got to practice it. So you get the feeling. So you say, oh yeah, that works, And so then I added spray shellac for the finish, and I added ball feet just to raise it off the floor. And I put some felt inside to help quiet the beads as the kids put them in the box. Now that was what I went through to make that box right there. Now I'm in the process of making a second box, an all new different way. And that's with my CNC machine, which I just got probably about 4 weeks ago. Okay. Start with the same material. All right. This is the rough stock here. I took some of the longer ones, glued them edge to edge for the top and the bottom, just like I did before. This is one of the screens, the software in the CNC machine I have is called VCarve. Right? And this is the tools you use to make the drawings. So you can, it's like a little CAD system that you can draw right there to make your drawing. Right? And I'm still learning how to use that. So I always had these parts drawn in a Libra, but I couldn't get the Libra's drawing into my CNC system. I had to convert it over to ViaCAD in order to make ViaCAD make a DXF file. Then I can move it into the system. All right. So that's what I did. Right? And then when I set them all up here, I drew the one here, and then I actually mirrored it and then shifted it over. And then I took those two, mirrored it, and shifted it over, so forth. That's how I got them all like that. Now, I did that because I didn't know that there was a app in the CNC machine. And so all I had to do was put one of them up here and say, what offset do you want? And it just duplicates it itself. So, yeah, so I haven't tried it yet, but I'll have to work on that. It wouldn't have mirrored it, it would just flipped that design. It would have been the same thing. All right, now this is the other side of the screen. Right? When you hit a button, it flips it so that this comes up. And you flip back the other one, you got the CAD part. All right, now this is where you actually do the machining. And this is where the tool path is on here. You can see that the circles around, and you can see the path going around the pizzas like that. And this is the types of different machining you can do. You can do edge machining, you can do pockets, you can do contours, you can do lettering, V-carves with a V-bit and all kinds of stuff. And I've only used the edge right now. And you can also see a 3D view of it, and you can rotate any way you want to do that to make sure that you've cut, you're supposed to cut all the way through it, all right? Or in some things, if you're doing very complex 3D work, you may have to look at a 3D view of it to find out if there's certain areas that need a smaller tool to be able to finish what you're trying to make. Now, some of these tools, if they're real narrow V bits, right, the point goes down to a 32nd in diameter down there. So that's we're getting into very tight areas, Okay, so this is the V-carve drawing of the side piece, right, that I need to cut out. And that's after I had stacked everything up, glued them together. Right? Here's my tool path around there. Okay. Now, this is something I learned on the internet, is how to clamp the wood down to the CNC machine has a aluminum T-track system on it, right? And that's for putting clamps to clamp your wood down, or to clamp your spoil board down. What you don't want to do is to cut into your T-track. So you take a piece of MDF wood, 3/4, 1/2 inch, something like that, MDF material, and you attach it to your aluminum bed, right? And then you attach your part to that. And that's what you drill down into or cut into when you're cutting, right? Some guys are even double insured. They put a spoil board on top of their spoil board, right? Because they definitely don't want to cut into their T-track, right? When first time I turned my machine on, you can jog it, but the controls, the first thing I did was run into the side, right? Because I was standing and looking at it the wrong way, right? That's how I learned which way you're supposed to look at it. You get your X and Y. Right? Luckily, I didn't hurt anything. So. But attaching the pieces, my parts were, I mean, almost size on size. So I didn't have a lot of room to play with. So I couldn't clamp it down per se. Right? So I had to find a different way to do it. So searching on the internet, guys developed this method, and it's very sharp. This is my stock material, and you take painter's blue tape. This is a 2-inch wide stuff, and I put blue tape on the bottom. Right. On my spoil board, I put blue tape in the corner that I'm going to set this on, and then I put a couple dots of super glue on the tape, stick the piece down, and that will not move. But when you're done cutting, you just pull the tape off the spoil board and pull the tape off the back part, and you're ready to go again. You know? And you don't have to worry about running into the clamps or problems like that. Yeah, yeah. And there's guys doing it on industrial machines with aluminum parts, doing it this way. The same thing.
We use double-edged tape. We tape our stuff down onto the table with double-edged tape.
Yeah. There's different, a lot of guys do that, right? I don't know what tape they use, but there's a lot of tape out there that'll hold, you know, like the carpet tape. And that's what I use a lot of stuff for turning. I use carpet tape. Sometimes lathe holding double-sided tape also. But sometimes some of those tapes is very difficult to get off of the piece, you know. So that's why I wanted to try this method here. Right?
I found on wood, there's a lot of times I'll use the blue painter's tape, and then I'll use double-sided tape. The blue tape off.
Oh, okay. That works good. Use both ways. Sure, it goes both ways. All right.
Something else I just saw to get Amazon's called Gapper's tape, which is almost like a duct tape that sticks really, really well, but it's designed, it doesn't leave any residue on whatever. So we use it like for running an extension cord across the stage, and you get it like 2 to 3 inch wide. That's super sticky, but it doesn't leave any residue.
Oh, wow. I have to look at Gapper's tape.
Gapper's tape.
All right.
For my scroll sawing, I use a 12-inch wide shelf contact paper. It's transparent and it's removable.
Right.
So, you know, you can put it down and it sticks like crazy and it doesn't move or anything like that. Might want to try that out.
All right. That's another idea. All right. Good. I'll have to look into both of those ideas. Very good. Thank you. Okay, doke. So here's my speeds and feeds I got set up on here. I'm using a DeWalt 611 palm router with an 1/8 inch solid carbide spiral upcut router bit. I'm going 22,000 RPM, 70 inches a minute feed rate. That scared me. The first time I cut my first piece, I was only at 20,000 and I was going 40 inches per minute. And that was still scaring me. Right. But the only problem is when I took the piece off, it wasn't cutting very well. Right. It was real rough and it's fuzz all over it on the edges and so forth. And the bit was hotter than hell. Right. It was less than 1,000th chip load. So I went on in it for speeds and feeds to find out about this stuff, studied it, came back. They actually want you to go at 100 inches per minute up in a little higher speed for that type of a bit. But my machine goes max at 100 and I wasn't ready to max it out yet. So I'm at 1,500 chip load, two cutting edges, going 1/16 of an inch deep. Right? And it just flies right through without a problem. right? So on the 1/4 inch thick piece, it goes through 4 times, okay? When I'm done, I can touch that tool and it's just warm. It's not hot at all. And I get a very nice clean cut, right? So I'm locked into those speeds and feeds right now. All right, so here's the first piece, the first good piece. All right, I'm working on here. So first thing I did is I did the holes. All right, now I use the 1/8 inch bit to do the holes also. Right, and you come down and instead of drilling it, I punch down and go in a circle. Go punch down, go in a circle like that. Okay, and that's how I made the holes. All right. Now I wanted a 3/16 hole. Well, actually, I measured my dowel rods this time. Okay, and that was what I programmed to. All right, and made the holes. Here's how the holes came out. Is that 3/16 or bigger? Maybe you can't see. They're not. It's quite a bit undersized. Okay. I was expecting the router bit to be a true 1/8 of an inch in diameter. Right? It wasn't. It was undersized for some reason. And not only that, you have to specify an offset. All right. I programmed to make 3/16 holes, but I wanted them bigger. So I programmed an offset to cut them bigger in the CNC software. Okay. And it says, if you want something bigger, you make plus offset. If you want it smaller, you make a minus offset. That made sense. So I made plus holes. Well, it made them smaller. A hole, you have to go minus to make them bigger. On the outside, you go plus to make it bigger. All right. So that's how you learn. Right? Yes.
On that slide there, all those holes, is that, you just program it and then the machine cut them all, drove all those holes?
Right. Well, it would come down and then circle around the hole.
And you go on to the next.
Yep. Yep.
Gotcha.
Yep. And it would just feed, it would do that 4 times for that hole, come up, go to the next one, come down and do it 4 times, so forth. Yep. And it just came right across the bottom, went up, went across that way, went up, went across that way. Okay. And you want to do all your internal things first and then do the outside, because as you're doing the outside, it may shift on you a little bit. Okay. Unless you really have it stuck in place. Right. And so all I've got is that blue tape with the super glue. And when I did it on this one, I actually put a whole stream, a whole line of super glue on there and put it down. All right. Now I just put a couple dots here and there. It holds it very well. I'll show you another way to keep parts in place also. All right. So there's what a full sheet looks like. All right. Then I said, just pull it up, take them apart. There's another different sheet with different style parts on it, with the longer side pieces. Okay. Stack of parts. These are all done on the CNC machine. There are some issues though that I've had and tried to work out. The holes being one. Okay. The other one is you have to set your X, Y, and Z 0 on your part before you start. Okay. Because that has to be in sync with your program. And you can set it to the top of your material, or you can set it to the bottom or on top of the spoil board. Okay. Well, I started setting it to the top of the spoil board, but then I got too complicated because I had to move it to set the X and Y. Okay. So I went back to setting it to the top. Then I can do all 3 at one time with one setting. Right? But you have to, when you're doing the Z, you jog it down real slow until it just touches the top of your wood here. Okay. You have to kind of bend down and look to see what kind of gap you got there. All right. Evidently, I wasn't down far enough because I didn't see any gap. That's where I set 0. And that's why I left material in here. All right. So I had to go to the sander and sand that out. Okay. It's about 15 thousandths. Okay. But if you set it right, it goes through with no problem.
Could you get away with just setting your Z, like both the top set, you set the way you had, and just have the program say, cut it to 16th of an inch for your spoiler board?
I haven't figured out how to. Yeah, the only way I figured out how to do that is to specify that the wood is thicker than what it actually is. right, then it'll go deeper. Right, but because I haven't figured out how to tell it to go minus yet. Okay,
Jerry, can you set your CNC to cut the ups and downs with it up, so it would actually cut those grooves in there rather than cutting them on the side of the board?
Yes, you could do that. I haven't done that yet either, but you'd have to use sort of like a ball nose end mill. And it would, because it's curved, you'd have to make many passes to do it, but you can actually do that too. Yeah. The other thing I found out was when I had all that painter's tape on there, it picked it up because it was like a fine dust of blue tape, right? And it left marks on the edges where it was cutting, all right? And it was a mess on some of them, you know. So all I did was took an edge of an X-Acto knife and scraped it off. Or I used a cabinet scraper sometimes, just scrape it off, right? But what I did was I just didn't use as much blue tape, and it worked better. And I think the 7 inches per minute stopped that also. Instead of when I was doing 40, I would get that. So.
Can you do that with a down cut, or is that just not working outside?
Yeah. It's better to use an upcut because you want to get the chips up out of the way. Yeah. Okay, so this was my first pieces that I made, and I wanted to test the alignment of the holes, make sure it was okay. And they lined right up. You stacked the pieces up, and the dollars just slid right through, not a problem. Okay. All right, now this was the actual piece that I'd made off the CNC machine here. Well, this was the first one. It's actually this part right here, this one. With the blue dowels this time. Remember, that's the drawing I'm trying to cut. And there's a test piece right there, just to make sure everything cut right. Okay. This takes a minute and a half. I'll only go through part of it here. But this is actually a V-carve animation of the tool cutting the wood. Okay. Right on your computer screen, so you can see what's going to happen. Make sure that it doesn't hit anything, you know, it doesn't get out of the way that you may have missed previously. But that pretty much is what it looks like when it's actually doing it. Okay. No, I went through the whole several times. Yeah, I'll show you why in a second here. Okay, now it's doing the outside of the other one. Okay, that's good enough. And now I'm getting ready to cut it. You notice I don't have as much tape. I just got them on the ends here. Okay, still held it in place. Okay. What happened? Oh, wait a minute. What happened? You see that? There's 2 holes in the left side. So that's supposed to be 2 holes over there, right?
I did not do that.
Before the animation that we just saw, all right, I made that test piece, all right, and I said, ready to go. Put it on there, put that piece on, started cutting, made the first hole and went over, made the second hole and I shut it off. That hole's in the wrong place. I could see right away on my stock, it was not in the right place. Now I have to stop to find out what happened, all right? Well, what happened was when I programmed this, I mirrored it over to do the other side, all right? I put the center line in the wrong place. So when it mirrored it too far. Okay. All right. That's how we learn. Double check.
You're doing a lot of learning. aren't you?
Double check everything. Yes. Question? Okay. All righty. So I went ahead, I changed it, put it in, and corrected it. So without that hole in here, that'd been a perfect piece. All right. The other thing here, Ron. Hold a second. These slots, this is like, here, slide it in there, it'll fit in. Maybe that's a little too thick. Try this slot, try this one. This may have been one I done on the saw. Okay. Okay. So these long pieces then, the slots on the bottom, and they go over each other like half lap type thing. All right. So that's a nice fit in there. All right. All right. When I made this one here, because this was made on the CNC machine, this came out nice and flat here and in the face. When I made that one, those pieces were jagged all over the place. All right. That's as much as 20 thousandths off. So I had to plane it down, sand it down. Okay. Then I had to measure the new thickness of each piece and try to cut my slot to fit that particular end of the side. All right. It didn't work very well. I mean, it came together, it looks nice, but there's some slop in there. Okay. So. All right. So now I'm putting blue tape down on the big piece, right? The top and the bottom. That's all the tape I use. Okay. Put it down in the machine. This is because it's so big, I want to make sure it glued down. So I've got like a big brass weight on the end down there and a couple of clamps there for maybe 30 seconds or so. Yes. Yes. And I'll say that in a second here. I turned the sound on, but it would blow us out of the room here. Because the routers noisy itself, the stepper motors are loud, and then I don't have a vacuum. If I had a vacuum running at the same time, that would be loud.
You can't even hear when the vacuum's going, trust me.
Yeah. So there's the piece cut out. Now, there's a tab in here. You program that tab in to keep that piece from moving on the inside. Okay. When you cut through. And you can specify the length and the height of those tabs and the location of the tab and how many you want on that piece. So in this case here, I've got one on the center of each side and each end of that piece. So it won't move on me. And those are about a ½ inch wide, about 50 thousandths. Because all I do is I take a chisel, put it on the waist side, hit it, and it comes right out. And then I just sand that area down. I'll probably learn how to make them smaller so I don't have too much to do with either. All right, now, yeah, I took one of the tops I had and did an engraving test with a 60-degree V-bit. This is a Captain America shield. Okay, so that's engraved about a 1/16 of an inch thick on there with the V-bit. I'm going to paint this then. This is going to be silver, blue, red, silver, and red, just like his shield is in Captain America. Okay. That's why we went with the blue bow rods.
How big is your table?
The actual table is 12 by 18 is the table size, but my work area is 12 by 13. Right? And 2 inches of the 13 is actually off the front of the table. Okay? It sticks out here, which was kind of strange. We didn't know why you could cut off the table. What they said was, you put a piece of wood mounted on end like this and do mortise and tenon. Right? I probably have never thought about doing that. I probably will never do that. I'll probably extend my spoil board over that far if I have a bigger piece I want to get in there. So. This is a laser. I also got a 2-watt laser with it. And 2 watts isn't very strong. You can't do much with it, right, except some slight engraving. You have to go around it a couple of times on wood to get a nice burning. This is on a piece of cardboard. And if you notice that the outside circle is not concentric to the others. Any idea why? It was programmed right. I put it on my spoil board too high, and when the machine went up to do it, it hit the limit switches and kicked it off. So now I've got big red lines on my spoil board. Don't go past this area. So I don't do that anymore. I'm still learning. Now here's the same thing. It's on the back of the top. This is lasered. You see, I didn't even sand it. Sand the glue off of it, and it won't burn through the glue. I tried doing this on a piece of white foam board, but it didn't work. It didn't do anything on there, and I think it was too much reflection from the white to do a burn. And also, I'm not sure if I have so you can adjust the heat volume, or burn volume, and I don't think I have it as high as it'll go either. I haven't tried that yet. I only did this in about 3 hours testing it one day. So, okay, this is another mandala. My wife repainted the bathroom in grays. We have yellow tile. She wanted, and we put in a new mirror. So I have a huge area of nothing but gray wall. She wanted something to go in there. So since I made that, I thought I'd make a picture, mandala picture for it, like that. So that's all those little dots. Right? And that's about a 12 by 18 picture up there. Okay. So yeah, we do it a circle, let it set and dry, come back, do a circle, come back, do a little bit here. Think about what the design I wanted to do that. Okay. Even at that, I don't know if you can see it, but I got a couple blemishes on it because my sleeve ran across wet paint, or I got a drop as I'm coming across with the paint. So, and that's on a piece of foam board. The end. All right. Thank you very much. Any questions? Yes.
Something about I saw on CNC machines, instead of having the manufacturer, do they warn you not putting it over vertical?
No, they don't. In fact, I think there's a couple of people out there that have a couple of vertical ones that do like a 4 by 8 sheet of plywood. Right? And it runs a little bit differently than some of the others. It's sort of got like a rope and pulley system, the one I've seen, instead of stepper motors and screws and stuff like that. So
I'm thinking of two advantages. Usually these things take up quite a bit of floor space.
yes.
So you can just mount this on a wall. And then the second part is, well, instead of having all the chips hanging on the board, backing it up.
Yeah.
As soon as it's cut, it's going to drop.
Right. Yeah.
And you have a cleaner area to put a pan underneath it.
Yeah, exactly. Yeah. Yeah. I don't see any reason why it wouldn't run like that. You know, I could probably take mine and do this and put it up. You know, I think I'd have to secure it to the wall somehow, because you've got the big gantry and the motor sticking out, so it's going to be off balance for sure. You know, but I think the stepper motors would work. It's no different to them. You know, and mine is all run by screws, so it's very positive. You know.
How much backlash there is, I think, on all the writing. What's designed to obviously.
Could be, yeah.
Go this way versus.
Right, yeah, yeah. And they have backlash nuts. I haven't looked at mine to see if I have it on mine. For about 1.5 years before I bought this, I actually made several sets of drawings of CNC machines. I was going to build one myself and did a lot of investigating and studying of the whole thing. And I said, for the cost of me to buy everything, to make it myself, and then have something screw up or I didn't do it right, you know, this one was on sale and you got the laser with it. So that's why I went that direction. So, yes.
Well, most of them are such low power units. If you were to put it on its side, you're gonna end up with more sawdust in your guides and everything else after a bit of time when you're coming up. Instead of cutting when you're going down when it's laying on its side, after a period of time, when they get more wear and shadow on it, it's not like you're getting an industrial.
Yeah, or you, yeah,
When it's hanging on the side, you've got all this extra weight.
right.
Like we are, they're not really built to, you know, pump a lot on.
Exactly, yeah.
So after a while, it will start to actually get chapped.
Sure. All right.
You want to summarize that a little bit.
Okay. You're saying that if you were to take a small machine like mine and try to set it on its end to do vertical cutting, after a while, I would get chatter because you would get wear in the screws and stuff from the weight. They're just not designed to work in that direction. One of the gentlemen asked if they'd make CNC machines in vertical. And I said, I've seen some on the internet, but they run off of rope and pulleys, I think, which is a whole different situation then. Yeah. Was there another question in the back? No? All right. Anybody out in the audience, in the home audience have a question? No? Alrighty. Thank you very much. I appreciate it. It's been a long time since I've done a presentation. I enjoy doing it, maybe more so than being over there. Thank you.
Thank you, Jerry. Okay, should we do the door prize? You know,